Hey guys, welcome back to the Ultralight Airplane Workshop. My name is Leon. In this video, let's talk about some more composite testing, but this time, let's do a slightly different test than the last beam test on the sheet, and let's do it on some composite sandwiches. In a previous video, we talked about possibly replacing aluminum sheet in an ultralight airplane design with sheets of carbon fiber, and we did some testing to see how plausible that idea is. Well, the logical extension to that would be, well, let's use a slightly more advanced idea on composites. And that would be these sandwiches where you have a layer of carbon fiber, a layer of some core. In this case, this is a PVC core, 1/8 inch thick. And then on the other side, you'd have another layer of carbon fiber. And by making it thick using the core, you make it really stiff. Now, by making it stiff, you can span a larger area than you could with sheet aluminum or sheet carbon fiber. And so potentially, you can leave out ribs and bulkheads and make your airplane a little bit lighter, at least potentially. That is if your sandwich doesn't get too heavy. But how long a span can we go? Well, that's what we need to figure out by using this test today. Now, the apparatus I'm going to talk about that I made and the method that I'm going to use with this apparatus is not one of the ASTM approved test methods. And that's for you guys who know what ASTM is, which is an organization that comes up with test methods for things like carbon fibers and metals and other things. Well, I think that's enough introduction. Let's get to it. In the last test we did a cantilever beam test where we held a sheet on one end, held it rigidly, and then put a weight on the other end, and we measured how far it deflected. And that was really to just kind of give us an idea of how stiff one kind of sheet was compared to another. It wasn't really going to give us any quantitative measurements, kind of more qualitative. In this test, we're going to do something similar but a little bit different. It's still a beam test, but in this case, we're supporting our piece of composite on two ends and then putting pressure in the middle and measuring how far it deflects. And that's what this rig that I've created is for. Now, this really doesn't follow any standard beam bending method. It's kind of something I just made up to help compare one of my pieces of sandwich to another piece of sandwich. And that's what this test is really only for, just sandwich testing. In other words, carbon fiber, a core, and then carbon fiber. It's not for the sheets that we had in the last video. So here's my setup. I've got these two pieces of 80/20 that I slide my sandwich into in this T-slot, and that's what supports the two ends. And it supports them fairly evenly. Since I have this 80/20 down on my mill bed, I know that they're fairly even on each side. And then I needed a method of pulling on it, and I need a method of measuring how hard I'm pulling on it. Well, how hard I'm pulling on it is handled by this gizmo right here. This is a load cell that's designed to measure a load in tension. What I've done is I've cut off the head of a 1/4 inch bolt. I screwed it into the top of my load cell, and then the other end is up into my collet. And what I can do is I can pull that by turning my quill on my mill. Now I can measure how far the quill moves using this dial indicator. It's got a magnetic base here, and it moves as I move the quill up and down. It changes this distance. Now on the other end of my load cell, again there's another 1/4 inch bolt that goes down into this 3/4 inch by 3/4 inch aluminum bar, and I made it big enough that it can move freely in there. It won't bind, because that can throw off my load cell reading. And then that attaches by a bracket to this 1 inch by 2 inch tube. That then comes down and attaches to another 1 inch by 2 inch tube through a 1/4 inch all thread. And then I put a little piece of aluminum here that actually puts the force on the carbon fiber piece. So when I move my quill up, it's putting a pull force on the carbon fiber sandwich. Now I measure how much force that is over on this, and right now it's measuring kilograms. In fact, right now this is the end of a test I've been running. I've already done a load test on this in both orientations because I have different fabric on one side than I have on another, and I want to find out how that affects the measurement. I can actually change the load a little bit by just pressing on it. So you can see it move there. Now you won't see this move until I loosen up the quill. I rotate this, so that is dropping it a little bit, and you can see the load dropping. As I drop down the quill, the load is dropping down. So there is 1/10 of an inch I've dropped it. Let's go back up. So about 7 kilograms there. Let's come down that 1/10 of an inch to 4, so it's about 3 kilograms. Now right now I have this piece deflected 3/10 of an inch. Let me get my other camera out here and I will show you how much it's deflected. So right there's a view pretty much right straight down the piece. I do have some issues with this setup and with my carbon fiber sandwiches. As you can hopefully tell on the camera, I'll bring it over to this camera. These sheets have an angle that I used sandpaper to sand into them so I wouldn't have a sharp 90-degree angle. So that it would make it easier for the carbon fiber to form around here without big voids underneath that epoxy would fill during the vacuum infusion. Well, I have an issue. When I go to put my carbon fiber in here, it doesn't come up on the flat part, it's actually down here on the angle. Whereas if I put it in this orientation, it actually is supported reasonably well on this flat. That may cause a slight difference in my measurements. I just don't know yet. So what I'd like to do now is do a measurement on one of these carbon fiber sandwich pieces. Now, like the last test, in this test, we are uniquely identifying each of our test samples. In this case, it's going to be SWVI is the prefix, standing for Sandwich Vacuum Infusion. This is going to be sample set number 5 because there's actually a set of 3, and this is the first of 3. Now in this particular one, you might be able to tell from the matte finish, we don't have a shiny smooth surface here on this one. And this is the one where I roughed up the mold surface first to see if I get a smoother or a better vacuum infusion on the mold surface, and I'd like to never got it separated, which I don't think I'll be doing that again unless I can get another hint on how to do it. But anyway, I want to test this. It's got spread toe, 2x2 twill on the mold surface side. On the back side, it also has a 2x2 twill, but this is 13 toes per inch. It has H80 vinyl cell core. There is a 1 inch by 1 inch hole pattern in the core all throughout, and they're roughly 1/8 inch diameter holes. Now I'm going to test this one with this side in compression first. So to do that, since it pulls up, this will be in tension, this will be in compression. So let's put it in like this. Now as you can see, as I'm putting this in, this thing is free to move however it wants to move, which helps to keep from putting unusual stresses on my load cell. I put this fence in until it touches, and then I back it off about 1/16 of an inch, a little more. And that allows this to freely move up and down so that it's not dragging the edges as it's going up or down. I want to make sure that it is centered this way. So I carefully place it there. I'm just going to eyeball it. Make sure this is fairly straight because it can swivel. Now I want to put this down. Now you may notice that I have this wire that connects the load cell to the indicator suspended by a little bit of twine. That's because if I just let it hang down, there's enough drag as the quill is going up and down that it messes with my measurement. So I have it up here where as it's going up and down, I really don't see any difference in the measurement. All right, now I want to look underneath, make sure there's some space between my part. And I actually, since it's measuring 60, I believe it's resting on there. So let's come back down a little bit. All right, now you probably can't see it, but there's just a little bit of space under there. Okay, I don't have to do any zeroing out. I'm still reading 0 on my indicator. All right, now what will happen as I start raising this quill up, it'll start supporting the weight of my part, and it was 62 grams. So as it's coming up and supporting that, I should see 62 grams show up here. So let's see what happens. So I start coming up. There, I'm taking some of the weight. Now this side's coming up, this side isn't, so I may be off just a little bit on my center. So it's showing 60 grams, so that's pretty close. Now what I want to do is keep coming up until I start seeing the weight increasing significantly. Now the other sides start to come up, so I got just a tad bit more weight. So I come up slowly until I start to see it increase. There. That means is both sides are now touching. So I'm going to back off. And right there, that's pretty close. That's close enough. Right there. I'm going to call that 0. So I'm going to adjust my indicator to show 0 right there. All right, we're ready to start measuring. So what I do in the early stages, because my part can have a little bit of twist to it, the early stages of lifting this is not necessarily accurate, but I go ahead and measure it anyway. So what I do in the early stages go up at 25 mils a stage. So let's go up. That was down. Let's go up. And then I lock it. Sometimes it likes to move when I get ready to lock it. There we go. And I'm going to record my deflection and my weight. So I want to mark down a number of things. My sample number, so this is my sandwich vacuum infusion. This is group 5, sample 1. Now, what I want to do is say that I have a 2x2 twill, and I have a 2x2 spread. Now in this case, the 2x twill is in tension. The spread is in compression. Now my initial deflection is 0.025 and my weight is 0.710 grams or 0.710 kilograms. In my previous sample where I did this, I went up to 50 mils, 75 mils, 100 mils, and then I started, instead of jumping every 25 mils, I jumped every 50 mils. I went clear up to a 300 mil deflection. Now I did not notice any audible cracking or failing at this 300 mils. So I think I'll get some pretty good numbers from that. So I'll go ahead and do that real quick. I think I'll point out something here that's interesting. I am now significantly different than the previous test. At a deflection of, where am I at? 200 mils. In the last test, I was at 4.1 kilograms and 4.5 kilograms, depending on which orientation I had it in. I have almost doubled that now. So that is very interesting. I'd like to point out something that you may have noticed. Over time, this value is dropping. It's not dropping really fast, but it is dropping. There's some kind of a relaxing going on in my part. At least I believe it's in my part. I don't believe it's a change in temperature of the load cell. I think there's something going on in here, which there's a number of possibilities, and one of them is that my cord is breaking loose from the skin, and so it's giving up some of its shear strength going across. Another possibility is some of my threads are breaking in this top part or the bottom part. So at the moment, since I don't have any acoustic equipment, I can't quite figure out what's going on there. But I think it's very interesting. In the first test, I went ahead and I just let it run for a long time until it stopped changing. Now that took around 40 minutes for it to stop changing. And it went from 7.25 grams down to 6.975 grams. So it was not a huge difference, about 250 gram difference. So that's not huge, but I thought it was kind of interesting that it's doing that. And it's still dropping here. So we started up around 12.845. So we've dropped about 40 grams so far. It's not dropping real fast. So I will probably continue doing the test where I watch it fall down, and then what I will do is I will let it relax, take all the load off, let it relax for a few hours, come back and test it again. Now, I did that on the first part. When I went back and tested again, the maximum load was dropped from 7.225 down to 7.210. So the maximum dropped down, not much, about 15 grams. So it's not a huge difference, but it dropped way, way faster the second time. I only let it run for, what, around 15 minutes. And it dropped all the way down to that 6.975. So there was something after I put that initial load on that never fully recovered. So that's something I'd like to figure out. So essentially that is my current process. What I'll do next is take the part back out of the jig, flip it over, and put it back in. Now that'll give me tension and compression values for both sides. And that will help me to quantify the tension and compression characteristics of these sheets when it's in the sandwich. I've got another, 13, maybe 14 pieces I want to test. I'm not going to make you suffer through all of that. So I'll go through and do all those tests, and I will make another video summarizing what I've learned, and I'll try to come up with some conclusions on what fabric I'd like to use in my sandwiches, and to figure out if these sandwiches might be able to do what I want to do. I'm going to compare them to the wing loading that I expect on the UWS-1 Ultralight. I'm going to do something now that I've been looking forward to for quite some time, and that's to try to do a little destructive testing. Now, this may fail. It could be that this will bend so far and these ends will come in far enough that this thing will just pop out of my holding rails. If that happens, fine. But what I'm hoping is I can get a failure. I'd like to find out how far this will bend before it fails. Now, that's really just for my own curiosity, really. In a practical application, as far as this is going to be bending, it wouldn't be usable. If this bends like, let's say, an inch before it fails, that wouldn't be usable in my real application. I need my part to be flexing very little. I don't want planes flopping up and down feet at a time, or rudders, or elevators bending so far that the hinges bind, etc. Let's start moving this up and see what happens. Now I'm recording this so that I can come back and see exactly what happened, how far it went before it failed. I'm going to be trying to listen for cracks. Now it's possible I won't hear much. It depends on how this fails. If it's just a foam that compresses and collapses, if that's the failure, I probably won't hear much. If the tension side is what fails, we'll probably hear that. Compression side, we may or may not hear that, which would be this side if it fails. Okay, let's get started. Okay, there's 1/10 of an inch. We're at 4 kilograms. 2/10, we're at 8 kilograms. So we've gone this far before. There's 13 kilograms at 3/10 of an inch. I can feel it pulling really hard on my quill now. There's 4/10 of an inch, that's 17 kilograms. Okay, there's 1/2 an inch, 21 kilograms. Okay, well, I exceeded the limits on my strain gauge. It can only go up to 50 pounds, which, I'll change the units here. Let's go back up. So, that's it. Okay, well, unfortunately, we didn't get a destructive test. I do have another strain gauge that will go up to 500 pounds. For this video, I'm not going to take the time to go ahead and switch out the strain gauges. What I'll do next is I will start testing these 13 samples. I guess it's 12 samples now. And tabulate the results, and then I'll make a video talking about what I learned about these various samples. And these samples have different cores in them, different density cores, different hole patterns in those cores, and different fabrics on the various sides. And I've made videos about most of these samples that I've made. Let's talk a little bit about some future testing also. I'm working on another rig that I'll be able to pull several tons on to do some more heavy-duty samples. In particular, I'll probably make some plates of carbon fiber so I can do some tension tests and compression tests and shear tests on those. And I'll be making videos of those tests, of course. Another thing I would like to do, and I probably won't do it with this test rig, because this rig was starting to pull pretty hard when I was trying to do that destructive test on this. So I don't think I will put the bigger load cell and try to destroy this now that I know that it can go up to 50 pounds of force and still not break. Well, I hope you liked this video. There's a lot more of these kinds of videos coming. And don't forget, we're also doing the videos for the design of the UWS Ultralight. And those are coming up too. If you haven't done it already, go ahead and subscribe to the channel and then click that bell button so you'll get notified when these videos are put up on YouTube.